Assalamualaikum warahmatullahi wabarakatuh. In here, we will present the material about matrix. Next. We are from group 3, consisting of my name is Arika Juarri, Alifia Nurul Falah, Annisa Rachmatillah, Andhini Ariestika Dewi, and Eva Natijatul Hanifah.
Definition matrix. Matrix is an arrangement of ranges with numbers around in rows or columns with broad delimits. The numbers around in the matrix are called elements of the matrix. Rows is an arrangement of horizontal numbers, while a column is an arrangement of upright vertical numbers. Matrix order is the number of row element and the numbers of column element of a matrix. If a matrix has E rows and G columns, then the matrix is order E times G. AE times G can be written. Types of matrix. Matrix are defined into several times involved. Number one, zero matrix. A matrix where enter element is a zero number. Number two, row matrix. A matrix that has only one row order one at a time G. Number three, column matrix. Matrix that have only one column are order E at time one. Number four, square matrix. A matrix where number of rows is equal to the number of columns order E at time E. Number five, diagonal matrix. A square matrix where elements are all zero except on its main diagonal. Number six, upper triangular matrix. A square matrix in which all elements below the main diagonal are zero. Number seven, lower triangular matrix. A square matrix in which all elements above the main diagonal are zero. Number eight, identity matrix. A square matrix where main diagonal is one, while the order element is zero. On the side, it is an exemplar of a type of matrix 3.
Next is metric operation. And first is metric addition and subtraction. The term addition and subtraction in the metric is if there are two metrics, say in the order A and B, that have 2 times 3, then the metric can be add and subtract. And the picture is an example of a concept from metric addition and subtraction. Next. And second is scalar multiplication on matrix. In the scalar multiplication operation, a metric is multiplied by scalar number. If it is known that matrix A and key are real number, then the multiplication with a metric is the metric obtained by multiplying each element A with key. And the picture is example of a concept from scalar multiplication on matrix. Next. And 3 is multiplication of two matrices. The product of two matrices is the product of having two matrices such as matrix A and B, and matrix can be multiplied as the number of column of a to the number of row of matrix B. And the picture is an example of concept from multiplication of two matrices. Next, and last is transpose matrix. The transpose operation of a metric is a metric that experiences the exchange of elements from a line to a column and vice versa. The transpose metric notation is A exponent t. And the picture is an example of a concept from transpose matrix.
Okay, the next material is determinant matrix. Next. The determinant of a matrix is defined as the difference between the product of the elements on the main diagonal and the product of the elements on the secondary diagonal. Next. The determinant of a matrix can only be determined on a square matrix. The determinant of matrix A can be written that A or A. To determine the determinant of a matrix, there are two rules based on its order, namely the order of 2 by 2 and order of 3 by 3. Next. The determinant of a 2 by 2 matrix. The picture is the concept determinant of 2 by 2 matrix. Next. The next is the determinant of a 3 by 3 matrix. The determinant of a square matrix with the order of 3 by 3 can be calculated using two methods, namely the Serous rule and cofactor expansion. However, the most frequently used method for determining the determinant of 3 by 3 matrix is the Serous rule, and the picture is the concept determinant of 3 by 3 matrix. Next. The step for finding the determinant of a 3 by 3 matrix using Serous rule. Number 1, place the first and second column to the right of the vertical line of the determinant. And then number 2, add up the product of the elements on the main diagonal with the product of the elements that are parallel to the main diagonal on the right. Then subtract the products of the element on the side diagonal with the elements parallel to the side diagonal. Next.
The next material is inverse matrix. Just like a number has a reciprocal, for example, 1/8 is a reciprocal of 8, a matrix has an inverse. Next. We write A inverse instead of 1/8 because we don't divide by matrix. The inverse of A is A inverse only when A times A inverse will give us identity matrix, and A inverse times A will give us identity matrix too. It is the concept of an inverse of matrix. And we just mentioned the identity matrix. It is the matrix equivalent of number 1. It has ones on the diagonal and zeros everywhere else. And the symbol of identity matrix is capital letter I. Next. 2 by 2 matrix. Okay, how do we calculate the inverse? Well, for a 2 by 2 matrix, the inverse is, like we can see in the PPT, or in other word, we can say, swap the position of A and D, and then put negative in front of B and C, and divide everything by AD minus BC. As previously stated, AD minus BC is called the determinant. Next.
Next, we will into question and answer. Next. For the example, we use 2 times 2 matrix. Question, the matrix is now as follows. Matrix A is equal to 1, minus 2, 4, 2. And matrix B is equal to minus 2, 4, 3, 1. For the question is, determine the value of A plus 3B, find the determinant of A, and find the inverse of B. Next. For the answer, determine the value of A plus 3B. We know matrix A is equal to 1, minus 2, 4, 2, plus 3 times matrix B is equal to minus 2, 4, 3, 1. And is equal to 1, minus 2, 4, 2, plus minus 6, 12, 9, 3 is equal to minus 5, 10, 13, 5. For the second question is find the determinant of A. We know matrix A is equal to 1, minus 2, 4, 2. And determinant of matrix A is equal to 1 times 2 minus 2 times 4 is equal to 2 plus 8 is equal to 10. And the third question is find the inverse of B. We know the matrix B is equal to minus 2, 4, 3, 1. And for the first step, we find the determinant of matrix B is equal to minus 2 times 1 minus 4 times 3 is equal to minus 2 minus 12 is equal to minus 14. And we can find the inverse of matrix B. Inverse of matrix B is equal to minus 1 over 14 times 1 minus 4 minus 3 minus 2 is equal to minus 1 over 14, 2 over 7, 3 over 14, 1 over 7. Next. This from our group. Sorry if there are mistakes or shortcomings. Thank you and wassalamualaikum warahmatullahi wabarakatuh.